Hi, folks. Welcome to 8.8 vectors. And so in this section, we're going to talk about the last part of chapter 8. And before we do that, let's take a look at what we've learned already this section. Okay, so we've talked a lot about sines and cosines, but beyond just a unit circle. And so in particular, we've looked at non-right triangles. All right, we've learned about the law of sines and the law of cosines, and we've also learned how to find area. And these are not necessarily new concepts, but they all apply to triangles that don't have to be right anymore. We've also taken a look at polar equations, converting between polar and rectangular equations and coordinates, some special types of polar graphs and recognizing what that looks like and being able to predict. And we've looked at polar form of complex numbers and how to work with those. And then in the last set of videos, we took a look at parametric equations. So another way of describing graphs, curves, that might be a little bit hard to describe using regular equations, but might be a little easier using parametric equations. And in particular, we looked at lines, circles, parabolas, and ellipses. And this last one is something new, just kind of planting the seed for what we're going to cover in chapter 10. Now, what's new? So in this last section of chapter 8, we're going to take a look at vectors. And in particular, we're going to look at sort of the basic concepts, like what is it? What do we use it for? We're going to learn how to do some computation with it. And we're going to learn how to find out certain things from it and what to use it for. Okay, so that's where we're headed. And in this first video, we're going to take a look at a few of the beginning ideas. All right, so first question up for us today: what are vector quantities? And when we're thinking about vector quantities, it's helpful, and in general, it's helpful to learn about what it is and what it's not. Okay, and so in this section, we're going to take a look at scalar quantities and vector quantities. Okay, so one scalar quantity that we might have heard of is mass. Okay, and mass is just sort of the amount of space that something takes up, but the vector quantity that kind of goes with it is weight, right? Because we all occupy a certain amount of space, but depending on the gravity in the situation, our weight might be different, right? So whether we are on Earth or maybe in a different gravitational field, or maybe how it feels different when we are floating in the water, we just feel a little bit different. All of that impacts our weight, but it doesn't change our mass. Another common scalar quantity is distance, right? And so we often think about things like, how far did we travel? For example, if you fly up to the Bay Area, that might be 500-ish miles, the distance, but the corresponding vector quantity is displacement. And the thing with displacement is it actually cares about your directionality, okay? Whereas distance is just kind of how far you go. So for example, you take a flight to the Bay Area and back, you've traveled a distance of about 1,000 miles, but your displacement once you get home is actually 0. So you've gone, you've come back, but ultimately it doesn't seem like you've gone anywhere. Okay. Another scalar quantity that's pretty common is speed. So how fast are you going? When you're driving in a car or some other kind of moving vehicle, you have a speed, but it doesn't really tell you which direction you're going. However, if we change the idea of speed to velocity, Now we're looking at a direction as well. So we're not just traveling at a specific pace, but we're also going in a specific direction, okay? Along with velocity, another common vector quantity is acceleration. Okay, so how quickly are you changing your velocity? But I want to list a couple others for scalar that don't necessarily correspond to the vector quantity, but time. All right, time is a scalar quantity. All we're doing is measuring how long something has happened. Temperature. All right, there's no sort of direction piece to that. It's just an amount. All right, and so the main theme that we're saying here is that scalar quantities, they have a magnitude, like an amount, okay? However, so magnitude only. However, vector quantities, they have a magnitude and a direction. All right, so one of them has magnitude only, the other has magnitude and direction, okay? And that's really the main difference that I want us to know here. Now, we're going to spend this section talking about vector quantities, so the idea of things having a magnitude and a direction. But before we do that, let's talk a little bit about the notation. So what is it going to look like when we write these or when we read them? All right, so common letters that we use for vectors, unfortunately, include U and V, okay? If you have handwriting where sometimes it's your U gets a little sloppy and your V gets a little rounded, it can start to be hard to tell the difference. And so one of the things that I would encourage you to do, make your V extra pointy on the bottom and make your U have a little tail. I think the tail helps differentiate it from the U and the V, okay? So I didn't pick these. I would have chosen ones that look totally different from each other, but U and V are common letters that we have here. Usually, they are bold letters, okay? So if you see it in a textbook, you'll often see the U in a bold face print and the V also in a bold, okay? Now, I'm handwriting a lot of this. I don't have time to do bold face letters here. If you do, that's fine for you, but that's what it looks like a lot of times in a textbook, okay? But we can also have them with an arrow. And what I mean by that is we don't use a bold face, we use the letter and we put the arrow on top. That shows that we have a vector. Or if we were using the letter V, we could also put a arrow on top of that. So you can use bold letters or arrows. I'm going to be using the arrows when I do these, just because, again, I'm handwriting. It makes it a little bit easier for me. Now, once we know the letters, what does it look like when we're actually writing out the specific forms? Okay, well, it turns out that we could have, for example, a U vector, and we might write it with a bracket, like a pointy bracket, A comma B. And A and B are just real numbers, okay? So it might look like this. And we would call this one standard form, okay? Or we might have something like this, AI plus BJ. And that one we call rectangular form. All right, so if you see these brackets, we call that standard form, but if you see the I and the J, that's going to be referred to in rectangular form. And since we've been working on sort of learning this fancier notation, we can also say that A and B, they must be in, and instead of using Z for integers, we're going to use an R for real numbers, okay? So we have A and B are real numbers, and then our standard form with the pointy brackets or rectangular form with the I and J, all right? So now that we've got that settled, let's go ahead and stop this video. In our next video, we're going to come back and actually do some of these operations, practicing that part. Okay, see you back here.